Okay, so we have gone through amplitude and midline changes, and we have gone through period changes. And if we take a look, that means we have dealt with A and D, right? Amplitude and midline, and we've dealt with B, period changes. So now we're going to work on our last variable, and that is C. Okay, so C is a phase shift, which is basically the same thing as a horizontal shift, right? It's the same thing that you've been dealing with for a while, since Algebra 1, basically. Okay. There's a little catch in sine functions and cosine functions, basically, because of how they're written. So I want to make sure that you see both possibilities. When you have these double parentheses, okay, then C is your phase shift. It is just C, whatever the variable is, that's how far it's been moved. Okay. There is this possibility where you will see a sine or cosine function written with just one set of parentheses instead of two. And that means that B has been distributed. Okay. So you have to basically undistribute it. And in this case, you will do C divided by B. So if you like it vertical, that's fine. C divided by B is going to be your phase shift if you only see one set of parentheses. Again, it's just because there is two different ways to write this. Some people consider the second form with only one set of parentheses the more simplified form, right? Because there's not two sets, it's been distributed. But you need to be prepared for either form that you will see. Okay, so as a reminder, again, you've been doing horizontal shifts for a while since Algebra 1. And the big thing about horizontal shifts or horizontal translations is that the sign is the opposite, right? It's always the opposite because in the original formula, there's always a minus there, okay? So if you see the minus, then it's going to the right. And if you see the plus, it's going to the left because, again, phase shifts and horizontal shifts are backwards. So as a reminder, this is the vertex form for quadratics, right? And H has always changed sign. When you got your vertex, it was always HK, so you always had to change the sign of H. When you did exponentials in Algebra 1, that same thing, that minus H, you always had to swap the sign. And when you got into Algebra 2 and you started doing radical functions, again, you have to change the sign of H. It's just, that's what it was. And your H was always your horizontal translation. Okay, so you do need to remember that you've got to change your sign. All right, so let's do some basics where we're just doing horizontal translations, and then we will put everything in, including period and midline and amplitude and everything. So we'll just work our way up. Okay, so again, this is just a phase shift. You're sliding it to the left or right. That's all it is. Okay, so to make it easier, I went ahead and graphed the normal sine function, right? Whether you graph it on strictly the positive side, right, from 0 to 2 pi or 0 to 360, or on the negative and positive side from negative pi to pi or negative 180 to 180. Okay, so it's basically just going to be horizontally slid. Now, in this case, we need to figure out how much. So it has one set of parentheses, but that's okay because there's no b value in front of x, right? So we don't have to worry about a distributive property. So in this case, it has been moved pi over 2 to the right. Okay, so since my period is 2 pi, right, pi over 2 is basically just one tick mark in this case, right? It's one step to the right because each of our tick marks, each of our steps is worth pi over 2 because our period is 2 pi. This will be important when we actually start changing the period as well. We'll have to know how many tick marks we need to move it. Okay, so in this case, again, pi over 2 to the right. So everything is going to slide one tick mark to the right. So instead of being at 0, 0, it'll now be at pi over 2, 0. Instead of being at pi over 2 at 1, that 1 will now move over to pi. Instead of being at 0 for pi, it'll now be at 0 for 3 pi over 2. Again, we're just sliding everything one tick mark to the right. Okay, instead of being at 3 pi over 2, the next one will be at 2 pi. And then the next one after that will now be at 5 pi over 2. So there's your new function. Everything has just been slid one tick mark to the right, basically, because of how our period works. Okay, so if you graph from the negative and the positive side, again, everything is just going to slide one point to the right. Okay, so from negative pi goes to negative pi over 2. From negative pi over 2 now goes to 0. From 0, it now goes to pi over 2. pi over 2 goes to pi, and then pi goes to 3 pi over 2. So again, there is our new function. It has just been slid pi over 2 to the right. Okay, so again, horizontal shift. Make sure you're checking, signs need to be backwards, right? So if it's a minus, it's actually going to the right. All right, so let's try a cosine function. Okay, again, normal cosine function, all we've done is put a horizontal shift into it. And this one, again, backwards, moves pi to the left. Okay, and again, our period has not changed. So pi is actually 2 tick marks, right? Because our period is 2 pi. Each one of our tick marks is a half a pi, right? Whether it's positive or negative. So it's going to go 2 tick marks to the left. So we take the whole function and just move everything over 2 steps. So instead of being at 0, if you were graphing just the positive side, that would now be at negative pi, right? And pi over 2 would now be at negative pi over 2. Positive 1 pi, if you go back 2 tick marks, was now be at 0. Okay, 3 pi over 2 goes to pi over 2, and 2 pi now becomes 1 pi. All right, and there's our new cosine function that has been slid pi to the left. Okay, that's really all it's doing, again, is just sliding left or right. Gets a little bit more interesting when we start combining with other stuff, but you'll see. So again, same thing. We are now going to take our one that we've done positive and negative and slide it 2 tick marks to the left. Okay, so negative pi becomes negative 2 pi. Okay, negative pi over 2 becomes negative 3 pi over 2. 0 becomes negative pi. Again, we're just sliding it over. Pi over 2 becomes negative pi over 2, and 1 pi becomes 0. All right. Okay, and there we go. And it's the same exact function. You can actually tell, see how this is at the top, in the middle, at the bottom, at the bottom. So this would actually continue in that same pattern. So it's the exact same function. That's why it does not matter which way you graph it. Okay, so let's start combining it with a few other things just to make sure we can see how this works. All right, so now we're actually going to change the period with it. Now, it has the double parentheses, which means our C is just our phase shift. We don't have to divide it to get it. So in this case, it's moving pi to the right, okay? And our period, right, remember that we're going to divide by B. 2 pi divided by 2 is just pi. And same thing that we were doing with period before, we have to cut the period into 4 equal chunks. So each step basically, or each tick mark is going to be pi over 4, which means we are actually moving this, because, there are 4 pi over 4s in 1 pi. We are actually moving this 4 tick marks to the right. Okay, so 4 tick marks. All right, so let me add a couple more marks on this just to make sure we have enough. Okay, so if we are moving this 4 tick marks to the right, and again, if you did your, let's just say we ignore the phase shift right now and you were just to graph this with a period change, okay? If you were graphing from the negative and the positive side, you would have started this, if your period was pi, right? You would have started this at negative pi over 2, and it would have ended at positive pi over 2, right? And each one, negative pi over 4, positive pi over 4, 0, each tick mark would have been 1/4, right? Because that's negative 2 pi over 4, negative 1 pi over 4, 0, 1 pi over 4, 2 pi over 4. That's how you would have graphed it, okay? So now you're moving it 4 tick marks to the right. So it would have started here. So now it's going to start 1, 2, 3 here. This is where you're going to now start your sine function, okay? And then it's going to go 4 more tick marks because that's how much we need. So 3 pi, I'm just going to keep adding a 4th, 4 pi over 4, 5 pi over 4, and one more, 6 pi over 4. Okay, so again, I'll draw the original function before the phase shift, just so you can see what this would have done. Okay, so pi over 2, or negative pi over 2 rather, and then negative pi over 4, back to 0, and up to 1, and back to 0. This would have been the normal function that you would have graphed, right, if it did not have a phase shift. So now everything is just being moved 4 places to the right. Okay, so this negative pi over 2 becomes positive pi over 2. 1, 2, 3, 4 tick marks. Okay, this negative pi over 4 down here would become 1, 2, 3, 3 pi over 4. Oop, I got a little bit of room. There we go. So down here. Okay, 0 would become pi, right? 4 pi over 4. So 1, 2, 3, 4 marks to the right. And then this one will become 5. That's supposed to be 5 pi over 4. Sorry about that. 5 pi over 4, and then back to 0 again. So this is the actual changed function with the correct period, right? Because we do have to cut our tick marks into fourths because of our period. So this is the actual correct function now that's been slid 4 marks to the right. Okay, so this is if you graph on the negative and the positive side. If you graph only on the positive side, if you're normally going from like 0 to 2 pi, you would have actually gone from 0 to pi in this case. So pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. This would have been your original shape, and it would have gone 0, 1, 0, negative 1, 0. Make it a nice dotted line. Okay, so that would have been your normal function, right? And if you're sliding it 4 tick marks to the right, okay, so we have to just basically keep going with our x-axis. 6 pi over 4, 7 pi over 4, 8 pi over 4, which is 2 pi. Okay, so everything gets moved 4 ticks to the right. So 1, 2, 3, 4. Okay, 1, 2, 3, 4. 1, 2, 3, 4. And we're still following that same pattern that sine does because we haven't changed the midline of the amplitude. And then down to 1, negative 1, and then back up to 0. So this is my new function. And if you take a look, these actually match very, very nicely. See how that 4 pi over 4 is at 0, 5 pi over 4 is at 1, see? And 6 pi over 4 is back at 0. So these are actually the same function. So it does not matter if you graph it on the negative side or the positive side, okay? It does not matter at all. And both of them would be counted as correct as far as showing your transformation and your new period. Okay, so let's take a look at a cosine one. All right, so same deal. We're going to change both the period and the phase shift. Okay, so this has been moved, again, double parentheses, so I don't have to worry about dividing. So it's going to go 2 pi to the left, right? And my period is 2 pi divided by b. So my period is 4 pi. Okay, we cut that into, again, 4 equal chunks always. So each one of my tick marks or each one of my x-axis points is going to be 1 more pi. Okay, and then we're going to go 2 pi to the left. So we're actually moving it to the left-hand side. So again, for those of you who graph only from the positive, you would have gone 0, 1 pi, 2 pi, 3 pi, 4 pi. That would have been your period. Okay, and I would go 2 pi to the left from there. So negative 2 pi, negative pi, right? And again, I have not changed my amplitude or my midline. Okay, so this is a normal cosine function. So if I graphed it only from the positives, okay, the normal from the positives would have gone here, 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 here. That would have been our normal function if we just changed the period. Okay, so everything has to get shifted 2 places to the left. So our new function is here. All right, so that's what our function should look like. Okay, and if you graphed on the positive and negative side, again, using a period of 4 pi, you would have graphed it So negative 2 pi, negative pi, 0, 1 pi, and 2 pi, you would have graphed it like this. Okay, so that's the original function. And if everything is being moved 2 tick marks to the left, I've got to add in a little bit more pieces here. So negative 3 and negative 4 pi. So everything is just going to slide down. All right, so that means this part would be, oh, there we go. That would be here, and then here, and then 2 tick marks to the left, and then here, and then back at negative 1. Okay, and again, take a look at how these graphs match. 0 is at negative 1. Negative pi is at 0. Negative 2 pi is at 1. So again, we haven't really, or rather the two graphs, sorry, that's positive 1 and negative 1. The two graphs are not any different. They are just representing them in two different places on the x-axis, and neither one is wrong. Okay, so whichever one you are more comfortable graphing, I take both as a correct answer. All right. So, and again, you will also see both when you're dealing with computer program outputs and like your calculator and the Desmos. Okay. So either way, we have changed the period to 4 pi, which is exactly how long it takes to go through one full curve, and that we have moved it 2 marks to the left, 2 pi to the left. All right. So now let's put it all together. Okay, now we're going to change the midline, the amplitude, the period, and the phase shift all at one time. And again, it's not difficult. If you want to graph everything other than the phase shift and then move everything, that's fine. The other thing that you can do, and I'll show you, is how to set up your x-axis and your y-axis, and then just go ahead and draw your shape in because the shape never changes. Okay, so this thing, 2 parentheses, it moves pi to the right and 1 up because of our midline. Our period, 2 pi divided by 2, is 1 pi. And we're going to cut that into 4 equal chunks, just so we know what each one of our tick marks is. And this function has been stretched by 4, which means it's basically going to change my y-axis like we did before. Okay, so let's put this all together, and I'm going to show you how to set up your x-axis. Okay, so it's moving pi to the right, and each tick mark is 4 1/4 of pi. So 1, 2, 3, 4. That's where your graph is starting. If you're doing the positive side only, 1, 2, 3, 4. Okay, if you're doing the negative to the positive side and your period is pi, you would have gone normally from negative pi over 2 to positive pi over 2. So that would have been 2 tick marks each, right? Because that's negative 1/4, negative 2/4, positive 1/4, and positive 2/4. Okay, so it's now gone 4 marks, right? 4 marks to the right. So instead of starting here, it's now going to start here. So I need to add 4 more marks. Okay, so it's not going to change the graph or the function rather. You can graph them either way. It does not matter in the least. Okay, so that's how you would set up your x-axis. You would figure out, okay, where would you have started originally? Now where are you going to start? And I'm just going to add the fourths in there since, each tick mark has to be a fourth. 4 and 3 pi over 4. Now that's probably kind of messy. 5, 6, this one's going to be 7, and then 8 pi over 4 on the end. Okay. So we've now set up our x-axis, and it works either way. You figure out where you're going to start, pi over right, or pi to the right, and what each tick mark is going to be. So you have to have that many to show that you are starting 4 to the right of your original starting point. Okay, so now we do like you did before with amplitude and midline. We're going to set up our y-axis. The middle of my function is now at positive 1. Okay. And it's going to go 4 above and 4 below that. So 2, 3, 4, 5. 2, 3, 4, 5. And to the bottom of that is going to be 0, 1, 2, negative 3. 1, 2, -3. Okay, that's all I really need as far as markings on my graph because I know what a sine function looks like, right? If I'm graphing it only on the positives, then it starts in the middle and goes up and back to the middle and down and then back up to the middle. Okay, so there's my new function. Okay, if I started on the negative side, right? If I started on the negative side, it would start in the middle and then go down and then back up to the middle and then up and back up to the middle. So this would be my normal function. It would have gone down, back up to the middle, and back down. So I'm starting at 4 places to the right. 1, 2, 3, 4. Middle, down, back up to the middle, back up to the top, and back to the middle. And again, check for placement. At pi, I should be at 1. At pi, I should be at 1. So these 3 points match with these 3 points. So again, just to show you, it does not matter which way you graph it. Okay, so that's it as far as putting it all together. We'll do some more practice in class, and that is it for graphing sinusoidal functions.